How do computers recognize faces in photos or understand spoken commands? We will explore the basic components of neural networks and how they learn to perform complex tasks. We will first define neurons, then discuss layers, how learning happens, and finally look at real-world applications. At its core, a neural network is inspired by the human brain. Its fundamental building block is called a neuron, often referred to as a node. Each neuron receives multiple inputs, processes them, and then produces a single output. These outputs can then become inputs for other neurons in the network. Neurons are organized into distinct groups called layers. The first group is the input layer, which receives the raw data we feed into the network. The last group is the output layer, which provides the final result or prediction. Between the input and output layers are one or more hidden layers. Hidden layers perform complex computations to transform the input data into a meaningful output. Information flows in one direction, from the input layer through hidden layers to the output layer. Now, let's understand how a neural network learns. Each connection between neurons has a numerical value called a weight. Weights determine the strength or importance of an input connection. Every neuron also has a bias, which is an extra input that helps adjust the neuron's output. Together, weights and biases allow the network to make flexible decisions. After processing inputs, a neuron passes its result through an activation function. An activation function decides if a neuron should be activated or fired, passing information. Further, common activation functions include ReLU, which outputs the input directly if positive, otherwise zero. Neural networks learn by processing vast amounts of training data. The learning process starts with an initial set of random weights and biases. When training, we feed the network an input and it makes a prediction. This is called forward propagation. We then compare the network's prediction to the actual correct answer. The difference between the prediction and the correct answer is the error. The network uses this error to adjust its weights and biases in a process called backpropagation. Backpropagation involves calculating how much each weight and bias contributed to the error. Then, it iteratively updates these values to reduce the error for future predictions. The network repeats this forward propagation and backpropagation cycle many times, improving its accuracy. Let's use an example of a neural network learning to recognize handwritten digits. From 0 to 9. First, we convert each image of a handwritten digit into a series of pixel values, which become the input. The input layer receives these pixel values, passing them to the hidden layers. Hidden layers learn to detect simple features like curves, lines, and intersections within the digit. Further hidden layers combine these features to identify more complex shapes that characterize each number. The output layer then predicts which digit, 0 through 9, the image represents. If the network predicts 7, but the image is actually a 1, it calculates the error. Backpropagation uses this error to adjust the weights and biases throughout the network. Through thousands of examples and repeated adjustments, the network refines its ability to correctly identify digits. Another powerful application is natural language processing, or NLP. NLP allows computers to understand, interpret, and generate human language. For example, a network can be trained to translate text from one language to another. Input layers receive words or sentences, converted into numerical representations. Hidden layers learn the grammar, syntax, and meaning within the language patterns. The output layer generates the translated text or answers a question based on the input. This process of trial, error, and adjustment is how the network learns to find patterns. Consider how crucial this continuous feedback loop is for the network to improve its performance. Over time, each correction, however small, brings the network closer to perfect recognition. In summary, neural networks consist of interconnected neurons arranged in layers. They learn by adjusting connection strengths, called weights, and biases through repeated training with data and backpropagation. This fundamental learning mechanism enables computers to perform tasks like image recognition and natural language processing. As these powerful systems continue to advance, they will keep transforming how we interact with technology and understand the world. Generate your own educational videos for free at eduvids.vercel.app.